Okay, today we have 55 jump game. You're given array of nums. You are initially position an array first index, and each element in the array represents your maximum jump length. Position as soon as you can reach index false. So if we start from 2, we can jump either 1 or 2. And then from 1 we can jump only 1, and then from 1 we can jump only 1. Okay, yeah, so we need to store all jumps somehow. So if we from 2, if we say dp, so what if we calculate length of, so brute force is obvious, right? We jump from 2, we calculate everything, and it will be square complexity for everything, or even more, but basically around square complexity. But what if we can use dynamic programming, and we first we calculate length of array, then we create dp as 0 multiplied by L length. So what is the size of this? 10.4, 10.5 can be 1000. Okay, we cannot create array, but how about we create set? And we iterate for the array for element in nums, and then we can tell index, and then we can tell that we can reach how far we can reach from here. We can say for e in, let's say x in a range e, we can say that our dp and last element we can say that from here, right, I plus x equal append I plus x, but it's not only this. We have to, like, for example, here we have 0, right, but we can be on 1 and 2, so we will add dp2, dp0, Now it feels like array to me, right? So we can say we can reach dp maybe. And we can say that dp append 0 because we are in 0 element, right? We started from 0. And here we can say if index in dp we can move forward. And also at the end we can say if dp, if L in dp, we return, right? So for example, we can be in 3, but now we add in to 4. Okay, let's give it a try. Yeah, let's add set. So it's always returning. Let's print dp. So we can be in 0, we can be in 1, we can be 3. 0, 1, 2, 3, 4. But we never in 4. Because 0, 1, 2, 3, 4. So index value in nums. So we on 0. So we create dp 0 plus 1, 0 plus 0, which is 0, 0 plus 1, which is 1, 0 plus 2, which is 2. So we have dp 1, 2. Then we go next. To 1. 1 in dp, yes. 1 in dp, yes it is. And we go, 1 in dp is 3. So we add 2, which is in dp, and we add 3, which is in dp, and we add 4. We must have 4. Why we don't have 4? Let's print dp after every element. So we can be on 0, so we can be on 1, zero, 1, 2, is it L minus 1? I don't think it is, but let's try. 0, 1, 2, 3, 4, so 3 in dp. Oh, it's 5. Okay, 0, 1, 2, 3, 4. So we are reaching 5th element here. So let's figure it out. We have 0, 1, 2, 3. And we have 5 elements. We have to reach 4th element. Why we're not reaching? So if we are so we have 1, but we should have 0, 2. So we can reach with element 0 we can reach 0.2. Timeout exceeded. Because I don't have to do all this. I can say if I plus x more than L, I will break. Yep. This is the thing. Let's see who did it faster. Oh, we're getting max jump every time. Okay. That's it for today. Thank you for watching.